I was telling the students last time that we had this session that with the math problems, I believe on the ACT they give you 60 problems to do, and I think it's only 1 hour, 60 minutes to just do that part. So the idea is you want to go through and do the problems as quickly as possible. Now what that means is some of the problems you should be able to do straightforward. That shouldn't take you too much time. Some of the problems may take you a little longer. So what you want to do is go through the problems that you can do quickly, and the ones that you can't do, mark those. And then you can always go back and work the ones that may be a little bit more challenging to you. So, so let's begin. Look at this problem here. An object detected on radar is 5 miles to the east, 4 miles to the north, and 1 mile above the tracking station among the following, which is the closest approximation to the distance and miles that the object is from the tracking station. So a problem like this, you want to be able to try to visualize what they're talking about first. So if you can visualize it, and then from there be able to draw some diagram to see what it's trying to say, and then solve it. So so you have a person at some station, let's say they're here, and it says the object detected on the radar is 5 miles to the east, and then it says it's 4 miles from there to the north. Let's say if we go 4 miles up to the north, and then it says above the radar tracking. So you think about maybe the base of a box, and if you travel along that the edges of the box, you get to the back, you want to go up on the box like 1 unit, or here 1 mile above. So think about this as being a rectangle, and I try to look at this here. We got, say for example, 1 mile above. So we're there at that spot. So we started, let's put that in red. We started here. You want to end up there. So from this point to this diagonal in that corner over there, and if you think about it, this guy, it forms a right triangle. This was 5 miles. Here then we're going up 4 miles. So we can find this, and I'm going to call this R. We can find R first. So let's go ahead and find that. And that's, so far we're just looking at the base of this box. We're going from one diagonal to another diagonal. We hadn't raised it up that 1 mile yet. That's a little bit tricky, but let's just stay in the base. And if I can extract this out, what this means is that I have something like this. So this is 5, this is 4, and I want to find here R. So this is a right triangle, so we just use the Pythagorean theorem. So we get R squared is equal to 5 squared plus 4 squared. That gives us 25 plus 16. So we get here R squared is equal to 41. Well, this implies that R is equal to the square root of 41. So now with that said, I'm going to now calculate where we're trying to get to from this initial red dot to that second red dot. Now if you notice, that's a right angle there. that spot there. So this R, which is the square root of 41, this is 1 mile there. So now this line that I'm trying to compute here becomes a hypotenuse for a right triangle. And I have a box in my office that I just put in the trash can. I should have brought it and could have actually showed you there with hands-on illustration. But this corner here, that's in the bottom base of that box. And then if I move up, that's what I'm doing here. So it looks slanted, but it's actually a right angle. It's actually a right angle. If you take a box and if you take the edge of this room here, so what we just calculated was an hypotenuse from this corner, let's say over here, calculate the hypotenuse. Now if I raise up 1 unit, isn't this line here with the floor, isn't that a right angle right there? So this is the 1 unit coming up. So I'm calculating now from here, and it's going down like that. So what I'm calculating now is going to be the hypotenuse. That square root of 41 is actually on the floor, right? So if I can put this in two-dimensional terms, this part here, let's call this D. I'm not that smart. D just stands for distance. Okay, so I didn't make that up. So here, if I put this here, this is 1, this is the square root of 41, and this is D. So again, another right triangle. So we have D squared, according to the Pythagoras theorem, is equal to that square root of 41, it's squared, plus 1 squared. So D squared is equal to 41 plus 1. We get 42. So D is equal to the square root of 42. And you can put that on your calculator, type that in. Get something close to like 6.5. So we'll say approximately. You get 6.48 and then some change. So the one that's closest to that. And it says the closest approximation. So that's good. So it'll be part A, 6.5. Any questions there? Okay. Secondly, so this is for numbers 22 to 24, but in the handout that I received, I think I only saw maybe a couple of those problems, 1 or 2. So, but anyway, this is what we have. At both quick car rental and speedy car rental, the cost in dollars of renting a full-size car depends on a fixed daily rental fee and a fixed charge per mile that the car is driven. However, the daily rental fee and the charge per mile are not the same for the two companies. In the graph below, line Q represents the total cost for quick car rental, and line S represents the total cost for speedy car rental. And we can see how those lines are depicted there. Here across, we get the miles driven, and then up and down we get the cost of the rental. So the question, it says Robert plans to rent a full-size car for 1 day and drive only 50 miles. So he wants to drive 50 miles, so we're there. If his only consideration is to incur the least cost, which company should he choose? So if we take this up, so the car that has the least cost here would be Q occurring there, because this side over here gives us the cost, and then we see the cost there for S. So it says quick car rental because the cost is $5 less. Quick car rental because the cost is $15 less. Well, if we look in between from the 40, and then it seems like the quick car is somewhere around 35, somewhat close to that, maybe a little bit under. We don't know, but we can estimate. So we know that it's somewhere around 35. So the difference between 40 and 35 looks to be 5. Either company, because the costs are equal, the costs are not equal, because the cost for one at 50 miles is about $35, and the cost for the other is about $40. So they're not the same. The difference is not 15, is way less than that, the difference between these two. Speedy car, because the cost is $5 less. Well, it looks here that the quick car is going to be less, and so it looks like the difference is around $5 or less. So here we choose F. Do you see that? Do you see that? We choose F, right? Does that make sense? Okay. And like I said, whatever happened to numbers 23 and 24, I don't know. But from last week, you put that information together with this, and those are the answers that they supplied. Let's keep moving. Kaya ran 1 2/5 miles on Monday and 2 1/3 miles on Tuesday. What was her total distance in miles Kaya ran during those 2 days? So if you were to find that, for that problem, what are you asking to do with those numbers? Just add them up. Very good. So we have 1 2/5 plus 2 1/3. And so we're adding fractions. We could take the 1 and the 2, add those together, gives us a 3. But here we have denominators 5 and 3. So we just find the least common denominator, which is 15. So that gives us here 1 and 15. 5 goes into 15 3 times. 3 times the 2 is 6 plus 2. 3 goes into 15 5 times. 5 times 1 is 5. It gives us 1 plus 2 is 3. Since we have the same denominators, we can add the numerators. 6 plus 5 is 11. It's all over 15. And so you get E. Okay. All right. Number 2, this expression here is equivalent to, we're going to combine the like terms. 2 times 3 is 6 times 4 is 24. Have an x. It's to the third power, second power, second power. If I have the same base, I add the exponents. 3 plus 2 is 5, plus 2 is 7. Then I have a y. That's 1y, 2 y's, y to the second. So we get 24, x to the 7th, y to the 2nd. You get h. Okay. Number 3, Mr. Dides is a teacher whose salary is $22,570 for this school year, which has 185 days. In Mr. Dides' school district, substitute teachers are paid $80 per day if Mr. Dides takes a day off without pay, and a substitute teacher is paid to teach Mr. Dides' classes. How much less does the school district pay in salary by paying a substitute teacher instead of paying for Mr. Dides' salary for that particular day? So what we want to do is try to compare salary to salary. Compare Mr. Dides' salary for one day in comparison to a substitute teacher pay for one day. Well, they give us directly that a substitute teacher would get $80 for each day. Well, since we're given the number of days that Mr. Dyer's salary encompasses, 185 days. So here we know that 22,507 divided by 185 gives us what Mr. Dyer's, what he would get in one day. So 1 day's salary for Mr. Dyers is going to be here 22,570 divided by 185. Okay. So that gives you $122. Right? Now 122 is not the answer. Right? So you want to be careful that when we read these problems, we read with understanding. 122 is not the answer. Just because it's up there and you get 122, you say, oh, I get the answer. 122, I see it. And you move on and put a big X right there on that. So, right? So here it says you want to compare his salary per day compared to the substitute teacher's salary. And then it says how much less does the school district pay in salary by paying a substitute teacher instead of the actual teacher. So if the teacher gets $122 and the sub gets $80, the difference you subtract is what you're looking for, $122 minus $80. I forgot to put my dollar sign there. So that gives you $42. That's A. Right? So just because an answer is there doesn't mean it's the right answer. Right? So again, if there's a question, please feel free to ask. And you never know. One of these days you may come to Calhoun and I may be your instructor. So got the next one. So far, a student has earned, this is a good one because I have students that ask me this very same question, and I would expect, around the time when a student is in a calculus class or a differential equations class, they should be able to average their grade in terms of what must I make on this last test to make an A or a B in your class. This is a typical, very good problem. So far, a student has earned the following scores on a 4 100-point tests. That makes it easy in terms of weighting this out. This grading period, they make a 65, a 73, a 81, a 82. What score must the student earn on the fifth and last test, and I took that to mean the fifth test is the last test, of a 100-point test of the grading period to earn an average test grade of 80 for the 5 tests? Do you know how to do that one? Any ideas on that? Divide by what? But you have another test out there that you don't know. So let's do this. Let X represent the 5th test. Okay. So if that's the case, so here I have a 65 is the first test, plus the second test, which is a 73, plus the third test, which is an 81, plus the fourth test, which is an 82, plus the 5th test. The 5th test is X. So if I get the average, that means add them all up, divide by the total number of tests. How many tests are there? Okay, say it again. Thank you. 5, right? 5 tests, right? They give you 4 grades, but they want you to find the 5th test. So there are 5 tests in all. Now, what score does he want? An 80, right? See that? So it's just a very simple algebra problem now. Let's see, when you add the 65 plus the 73 plus the 81 plus the 82 gives you 301. So here I have X plus 301 all over 5 is equal to 80. Right? Multiply 5 on both sides, you get x plus 301 is equal to, what's 80 times 5? Very good, just 400. So x is equal to this 400 minus 301. So he has to make what score on this fifth test? 99. So at least, so he has to make a 99 or even a 100, right? To ensure his B for the class, to ensure the 80. Does everybody see that? Okay. So that's J. Let's look at the next one. The oxygen saturation level of a river is found by dividing the amount of dissolved oxygen the river water currently has per liter by the dissolved oxygen capacity per liter of the water, and then converting to a percent. If the river, matter of fact, let's stop there and just write that out, because they're telling you the formula that you need to be able to calculate with these numbers. All right. So it is saying here that the so-called oxygen saturation level it's equal to, here, by dividing the amount of dissolved oxygen the river water currently has. So here, this is the dissolved oxygen here the river water currently has per liter, and then dividing that by the dissolved oxygen capacity per liter of the water. So here, so if you will, and then it says, and then converting that to a percent, so that's times 100%. Right. See, I need to put this over to the side. All right, so let's see. So here it says that if the river currently has 7.3 milligrams of dissolved oxygen per liter of water, so that's 7.3, and it's in milligrams. And then it says, and the dissolved oxygen capacity is 9.8 milligrams here per liter. What is the oxygen saturation level? This is also times 100%. Well, you get what you need then. Just divide 7.3 by 9.8. Multiply that times 100%, and that gives us 74.49%. So that's closest to D, 74%. Is that okay? Okay, the next one. A rectangular lot that measures 150 feet by 200 feet is completely fenced. This is 150 feet. This is 200 feet. Well, if it's a rectangle, then opposite sides are said to be congruent, parallel, and equal. So this down here is also 200 feet. And over here, 150 feet. So what's the approximate length in feet of the fence? Basically, what's the parameter? So the parameter is twice the length plus twice the width. So just add up the sides. So you get 400 plus 300. We get 700 feet. Okay. Well, a little algebra. The expression a times the bracket b plus parentheses c minus d is equivalent to, we're going to keep that a on the outside. Let's simplify the inside. So when we deal with parentheses and exponents and brackets and that kind of thing, you want to try to go inside to the innermost core of the onion and then just work your way out. So we're going to go in the inner parentheses, the c minus d. Let's simplify that. So here we get the b plus, we can just drop the parentheses, c minus d. Now we distribute this a through. We have ab plus ac minus AD. So we look for that, AB plus AC minus AD. That's that first one. Okay. If 4x plus 3 is equal to 9x minus 4, then x is equal to, just again, a straightforward algebra problem. So you have the 4x plus 3 equal to 9x minus 4. With algebra problems, we want to, in solving, if it's linear, which is what this is, linear means that the highest exponent is 1, x to the first power. So it's linear. It's going to give us a straight line graph. To solve those, you want to get the variable expression on one side, get the numbers by themselves on the other side. So here, you can subtract 9x on both sides, or you can subtract 4x on both sides. I want to subtract 4x on both sides. So you do that. We get 4x minus 4x plus 3 is equal to 9x minus 4x minus 4. So it gives us 3 is equal to 5x minus 4. Add the 4 on both sides. So 3 plus 4 equal to 5x minus 4 plus 4. So we get 7 is equal to 5x. And it should be straightforward there, just dividing both sides by that 5. We get 7 over 5 is equal to x. Then we look to see if we can find that, and it's that first choice. Okay. All right, this is a good one. This is a problem that you have to think a little bit, and this would be a problem that, say for example, if I was taking the test, I'd probably mark this one and come back to it. And you won't know until you read to see what it says to see if that's going to be one that's going to be somewhat of a challenge. So write two numbers. So what two numbers should be placed in the blanks below so that the difference between the consecutive numbers is the same. Consecutive means right after each other. So it can be consecutive in terms of 1, 2, 3, 4, 5. So the difference there would be x, comma, x plus 1, comma, x plus 2. Or they could be consecutive even. And if that's the case, then it's x, comma, x plus 2, comma, x plus 4, celery. So here, but then it throws in a catchy hook there. It says that so that the difference between the consecutive numbers is the same. What does that mean, Kennedy? I can remember your name because we had a president named Kennedy. Okay, go ahead. It says difference, though. What does difference mean? Exactly. You own it. You own it. So what we'll do is, since we don't know what those numbers are, we use algebra. If I don't know what something is, I'll call it x. X. So call this x. I have another guy over there. I don't know what he is, so I called him y. Okay. So it says that so that the difference between the consecutive numbers is the same. So if you take two of these numbers and subtract them, that's supposed to be equal to the difference of the two other numbers subtracted, right? You see what that's saying? What it's saying, if I use the math to write it out, it's saying that x minus 17 is supposed to be the same as y minus x. That's the same thing as 41 minus y. The numbers must be consecutive. They must be right next to each other. If they're right next to each other, take their difference, and all those differences are the same. So, so what I have, if I look at that, I have x minus 17 is equal to, let's look at the one with the numbers, 41 minus y. So if that's the case, then you can look at this as being x plus y is equal to 41 plus 17. Added y on both sides, added 17 on both sides. So here we get x plus y is equal to 4, 5. It's just 558. So I know so far that x plus y is equal to 58. Now watch this. I also have here, yes, that x minus 17 is equal to y minus x. So what I'm going to do is I'm going to add x to both sides. So I get 2x minus 17 is equal to y. Then I get 2x. I'm going to add 17 to both sides, subtract both sides by the y, gives us 2x minus y is equal to 17. Now, I didn't tell you on purpose, what do I see in terms of how to solve this? Do you know what I'm thinking? Because to be able to see where you want to go helps you to solve the problem. And sometimes other people can't see it, but that's okay. But do you see where I'm trying to go? I'm trying to solve this by what method? What type of equations that I have boxed here, these two guys together are called what? If I put them together, this is a of equations. System of equations, right? Have you seen that before? If you have two equations, they solve these two equations together simultaneously as a system, and you can use the elimination method. Does that ring a bell somewhere? The elimination, Gaussian elimination, if you will, right? So that's what I'm thinking. Now you can do that. This is x plus y is equal to 58. And then this is 2x minus y is equal to 17, right? So you can solve that. So let's see. So if I solve that the way it is, I'm going to, notice this is plus y minus y, so if I add the corresponding parts, x plus 2x gives me 3x, y minus y goes out. So then I add the 58 plus the 17, 5, 6, 7, 75. So x is equal to 25, right? So that's x. I was looking for x, but also I want y. No problem. I can find y because I have here x plus y is equal to 58. I have x, that's 25. plus y is equal to 58. So y is equal to 58 minus 25. So y is equal to 33. Now, I will say this. It's one or two more ways you can solve that. It doesn't matter which way you choose, which path you like. It'll still get you there. Okay? That's just the path that I chose to solve that. And so the two numbers is 25 and 33. Looks like this guy right here, part C, kind of got fuzzy there with the copying. Any questions about that? You see how that guy is more involved to that? So you would definitely want to circle that guy, come back to it, right? The ones you can do quickly, solve those. And so you got 60 problems, go through them. This guy right here is a quick problem, number 10. Solve that right now, And then you get to a problem that's kind of like that, kind of quick, solve it, If it's kind of more detailed, you look at it, can I solve it in 30, 40 seconds? If not, circle it, come back to it. So here, if x is a real number such that x to the third is equal to 64, well, so it's telling us that the cube root of 64 is equal to x. So x is equal to the cube root of 64. Well, that's just 4, right? And even on just, if you kind of, don't know, just you got your calculator, you just plug that in your calculator, it'll give you 4. And it says x squared plus the square root of x. Well, x is 4, so this is 4 squared plus the square root of 4. So that's 16 plus 2. That just gives you 18. See how, like I said, that's a quick one that you can kind of look at that guy directly and be able to solve it without no problem. Now, again, if there's a question about something, please ask, because a lot of times the person that's next to you, they may have the same problem, but they don't want to ask because they think you know. And I've had a class that I've taught, and one student came and told me later because they didn't do well on the test. And I said, well, how come you didn't ask any questions? Well, I thought everybody knew the stuff, and so I was just like, I'm not going to ask. And I said, well, you see now that nobody really knew, but y'all were kind of looking like y'all were scientists already, that you knew all the answers, and I can't read your mind, and people think that of teachers and preachers that we can read folk minds, and we can't. So, yes. A formula for the volume of a sphere with radius r is given there. If the radius is a spherical rudder ball, which is 1 1/4 inches, so that's the radius. So here, if r is equal to 1 1/4 inches, we convert that to an improper fraction. So that's 5/4 for the radius. We use the formula. We thank them for giving us the formula. So that becomes 4/3. Here I'm going to use an approximation of pi 3.14. It's not equal to that, but it's somewhat close to it. So I put a tilde there to say it's an approximation. It's not it exactly, but we get close. We get close enough. And then this is times the radius, 5/4, and that's to the third power. And so now, on your calculator, you just punch those numbers in. So I get something a little bit bigger than 8, like 8.177. And this, we would say C. This is what is the volume to the nearest here, cubic inches. Just the closest one. Okay. If a marble is randomly chosen from a bag that contains exactly 8 red marbles, 6 blue marbles, and 6 white marbles, what's the probability that the marble will not be white? A couple of ways you can do this. You can do this by a direct method, by computing exactly what it's not, or you can use the complement rule for probability. The complement rule says that, well, one, it says that all probabilities must be between 0 and 1. So they're going to be a fraction. All probabilities are between 0 and 1. So if I know the probability of something, let's say A, then the probability that it's not is going to be 1 minus the probability of A. So if I know that something, the chance of this one thing occurring is 30%, so the chance of it not occurring would have to be 70%, right? That's one way you can do it, by using the complement rule. The direct method is basically look at, first add up all the total that we have here. So the total number of marbles, right? So is that 20? All right. And then the probability of selecting not white is equal to, add up what's not white. What's not white would be the 8 red marbles, and here the 12 blue marbles. So you get 6 plus 8, you get 14, all over the total number of marbles, 20. So you get 7 over 10. Okay. Yes, ma'am. Yes, yes. And I don't know how it is with you all in high school, but this is college, and you go and come as you please. Okay? Yeah. You can go get something to drink, get something to eat, you know. You can call your mama, you can call your papa, you know, call your friend. I'm thinking about Ray Charles, and call your mom, call him. I'm going to send you back to Arkansas. But anyway, these kids. Is that okay? Okay. Did y'all see that one? Did you see that? The problem? Did you? We get it? Good. All right. Now see if you all can help me out with this. I'm doing all this talking. I'm about to get hoarse, so and I don't have my drink with me. So the number of students participating in fall sports at a certain high school can be shown by the following matrix. Here there are 40 who are in the tennis, 60 in soccer, 80 in the cross country, 80 in the football. The athletic director estimates the ratio of the number of sports awards that will be earned to the number of students participating with the following matrix. Here, 0.3 for tennis. If you think about that in terms of percentages, they're saying 30% of the students will get an award in tennis, 40% will get an award in soccer, 20% will get awards in cross country, and then 50% will get awards in football. So given these matrices, what is the athletics director's estimate for the number, or the total number, of sports awards that will be earned for these fall sports? Right. What do you think? How would you approach that? You know, Lauren, you can talk to me. Kennedy? Add up what? The 40, 60, 80, and the 80? My question, why would you do that? Why would you do that? Which, Yeah, what's your reason? Anything you do in life, you want to have a reason why you're doing it. Okay. Now, let me show you what's happening so you can see it. You can see what I see. That second matrix with the point 0.3, the point 0.4, the point 0.2, and the point 0.5, these are numbers that the AD, he's estimating about the percentage-wise who would, from each sport field, who would get a certain number of awards. So he's saying here, these decimals, if you multiply by 100%, you get 30% for tennis. But 30% of what? You see, the percent is an operator. It wants to operate on something. 30% of what? 30% here of tennis, 30% times 40, right? This is 40% of soccer. How many people you have here in soccer? 60. So basically, what's 40% of 60 people in soccer? Here, this percent is also, it's an operator. An operator basically is a mathematical term that it wants to apply itself to a number to get something meaningful. Without it, just operated by itself, it's really nothing. So if it's a derivative by itself, it's nothing. That derivative wants to operate on a function, and then we get something. So the percent becomes an operator. So here, 20% cross country of what? Of 80. So the 40, the 60, the 80, and the 80, these are the actual numbers of students who are in those sports. So now what you want is, what's 30% of 40? What's 40% of 60? What's 20% of 80? What's 50% of 80? Once you get those numbers, add them up, and that's his total estimate of how many he supposed will receive sports awards for that particular year. Do you see that now? So basically all you're doing is you're saying that his total estimate is equal to here the 40 times 0.3 plus the 60 times 0.4 plus the 80 times the 0.2, and then plus the 80 times the 0.5. Okay, what did you get for that? So what did you get for that one? Hmm? 92. Yes, ma'am. Thank you. You got it. Good job. So let's see here. The following chart shows the current enrollment in all of the mathematics classes offered by Eastside High School. And we got that chart there. It gives the pre-algebra, algebra 1, geometry, algebra 2, pre-calculus, the section, the period, and the enrollment. So number 13, what is the average number of students enrolled per section in algebra 1? Okay, what is that? Can you work that out? Let me give you a couple of minutes. And let's do this, because I want y'all to communicate. What are you doing? What are you doing? Yeah, all of it. For this problem, what are you going to do? Okay, you add up what? Very good. And then you divide by 3. Perfect. And you get what now? So you said 24 plus 25 plus 29 divided by 3, and that gave you, you got 26. You get 26. Very good. Yep, you got it. So that was the 23 plus 24. I'm sorry, I'm looking at that. That's Algebra 1. So it's 24 plus 25 plus 29. 20. Okay, good. So now looking at that same chart, the school owns 2 classroom sets of 30 calculators each, which students are required to have during their math class. There are 2 calculators from one set and 6 calculators from the other set that are not available for use by the students because these calculators are being repaired. So the working calculators so here is 2 from 30, so it's 28 for one class, and then 6 from 30, 24 for the other class. So it says now, for which of the following class periods, if any, are there not enough calculators available, for each student to use a school-owned calculator without having to share? So we got 24 and 28 calculators. So which period would not have enough calculators for the students to share? All right. What say you? Is it period 2 only, period 3 only, period 4 only, periods 3 and 4 only? There are enough calculators for each class period. Period 1, 2, 3, 4, period 6. Seems like there's not a period 5. Period 5 may be my favorite period, lunch. So which period would have basically more students than calculators? 4. That's what I got. Is that what you got? Period 4 only? And you know, the thing is, it's kind of funny how they have the numbers, because you got 28 for one class that you have calculators for, and then you have 24, you know, for the other. And so are you running the scenario on 2 classes, or is it just one class? Well, to me it looks like if this is for which of the following class periods, if any, are there not enough calculators available for each student to use a school-owned calculator without having to share. So it looks like definitely period 4, there it has 29, but you only have 28 calculators, so you got one student that's going to be short. And so, you know, that becomes an issue. And then if you have anything over 25, say for example, like, well, the 29 would play in that. This 25, that's period 3. But my thing is, you got 28 for the other, you know, for the other period calculators that they can use. So it becomes kind of strange in terms of how they're phrasing that. Period 4. Say, for example, if period 4, you got 29 students, so you got 28 calculators here. So if that class, they won't be able to use the calculators because all the students won't have one. And then you have this other class over here with 24 calculators, so then that would knock out period 3, right? So there, if you think about it, to kind of answer the question, because they raised this, you got 2 classrooms, right? So one has 28 calculators, one has 24 calculators. So it looks like periods 3 and 4 only, if you're looking at those together. So you would probably best to pick D. This was a good one. I like this one right here. Not hard, but if you like math, it just makes you smile. No? Makes you cry? Oh, boy, it's going to be rough. Okay. So what expression must the center cell of the table below contain so that the sums of each row, each column, and each diagonal are all equivalent? Well, let's see. And we can call this A. Call that A. So each row has to add up to the same thing. So this is 6x, right? This down here is 6x. We're looking good over there. If I go up and down here, also 6x. So that means that when I cut through that diagonal, that has to also add up to 6x. So if I just take this guy, so I have negative 2x plus a plus that 6x has to equal to 6x. So if you will, if you subtract both sides, looking at this equation here, and what is your name again? Tatum. You know what? I knew that. I was going to say that from last week, but I just, sometimes I forget. Okay. You wouldn't by chance have any pork skins right there, would you? Okay. Nah, I thought you had pork skins. I'm just joking. I don't even eat pork skins. But I tell you what, back in the day, we used to run you for those pork skins. You know, that's some good stuff. I do not touch pork anymore. But it was good in its day. So if I take that equation, I have negative 2x. Subtract that 6x on both sides, so I get negative 2x plus a is equal to 0. Do you see that? Subtracting 6x on both sides, right? And so a has to be 2x. Number 17, point A is to be graphed in a quadrant. We have 4 quadrants, 1, 2, 3, 4 listed there. Point A is to be graphed in a quadrant, not on an axis of the standard XY coordinate plane below. But here's the criteria. If the X coordinate and the Y coordinate of point A are to have opposite signs, then point A must be located where? That's my question to you. X and Y must have opposite signs. So one is positive, the other is negative. One is negative, the other is positive. Well, if you think about it, okay, the first quadrant, X is positive, Y is positive. The third quadrant, X is negative, Y is positive. The third quadrant, X is negative, Y is negative. The fourth quadrant, X is positive. I don't want that there. And Y is negative. So what quadrants? 2 and 4, right? Okay. Everybody happy now? Okay. Don't y'all all shout at one time. No. Okay. Kareem Abdul-Jabbar has four sweaters, if I can read, 6 shirts, and 3 pairs of socks. How many distinct outfits, each consisting of a sweater, a shirt, and a pair of socks, can Kareem select? There's a principle here, and that principle is called the multiplication principle. It's the principle of selection. Take one from here, take one from there, take one from there. Then what I have left from the first bag, I pull another one from there. Second bag, I pull another one from there. Third bag, I pull another one from there. How many choices do I have for each one? So here's what you have. You got the sweaters, you got the shirts, you got the pair of slacks. So if I'm selecting, because it says here that you got to always have a sweater, shirt, and slacks. So for the sweaters, I have 4 choices. I pick one, but I have 1 out of 4. Here I have 6 shirts. Then here I have 3 pairs of slacks. And the total number of distinct outfits that I have is the multiplication of all 3. Okay. That's called the principle of, as a matter of fact, if I can go deeper, it's how multiplication originated. It was God who said to Noah, how many sheep do you have? How many camels? How many ox? And then from all of that, because Noah had to go and he had to make this selection, he had to chose from here, began to multiply. And then God said, now take 2 of each kind. Right? So here, this is the principle of multiplication. They call it the multiplication rule. Okay. If a rectangle measures 54 meters by 72 meters, what is the length in meters of the diagonal of the rectangle? So if I have a rectangle, and you want to calculate the diagonal, that long side is 72 meters. This side over here is 54 meters. If it's a rectangle, I know that here I have a right angle form. So you're just looking for the hypotenuse. So what is the length? So you get r squared is equal to 72 squared plus 54 squared. So r is the square root of 72 squared plus 54 squared. And then on your calculator, you can simplify that. So what'd you get? 90. Got 90? Okay, good. Could you all make sure that he gets one of those copies? Does he have one? Okay, good. All right. It's kind of fuzzy on this one, but I think we can kind of make out, bless you, what we have. For all positive integers x, y, and z, which of the following expressions is equivalent to x over y? So you kind of run through them. Here the z's cancel out. Z divided by z cancels out. There you have left x over y. Well, that's what you're looking for. That's the answer. But if you simplify everything else, this is x squared over y squared. That's not the same as x over y. And then here, this is y divided by y cancels out, x divided by x cancels out. That's equal to 1. And that is, these last two, they're already simplified. So it's that first one, right? Which is the slope-intercept form of 8x minus y equal to minus 6 equal to 0. When they say slope-intercept form, how does that look? What does that say, the slope-intercept form? Okay, very good. So here, y is equal to mx plus b. So what's m? What's m called? The slope, and b is the y-intercept, right? So m is the slope, and b is called the y-intercept. So we get the idea, slope-intercept form. So basically all they're saying is just to get y by itself. So if you don't mind, you can do it in one stroke. Just add y to both sides. And that gives you 8x minus 6 is equal to y, or y equal to 8x minus 6. 8x minus 6, that's that guy right there. You're done. Okay? Is that okay? And make sure that, I think I had the form for the email addresses, so we can get the young man's email address so we can send him a copy of all this stuff as well. Okay. Which of the following is a solution to the equation? Now, can you all see that? Is that x squared minus 36x equal to 0? Is that what that is? Okay, so I'm going to take your word for it. Oh, brother, I'm going to take your word for it, okay? 36x equal to 0. How do we solve this guy? Talk to me. What's your name, young man? Deron? All righty. So how do we solve for x? What do we do? Talk, Tatum. So you're saying to write x squared equal to 36x? Okay. Okay. Anybody else? Is that Lauren? Talk to me, Lauren. Oh, that was Kennedy. Oh, okay. Okay. I wouldn't know what to do with that, like that. I mean, how would you break it down? You're just going to pull it out? So it sounds like to me, you have an answer already in mind. Which, okay. Well, here's the thing. The strength of the problem is never just the number. The strength of a problem in algebra is always its biggest term. The biggest term here for us would be the x squared. Right? The biggest term for it's a polynomial. So have you seen the dragon before? You seen the dragon? It has a big tail. The dragon has a head, right? So if you're going to kill a dragon, what do you go for? You don't go for the tail, you go for the head. That 36 is part of the tail, right? You want to kill that dragon, you want to get to the head, right? So the head is his biggest strength. In computer programming, we call that head the big O. So any function, any algorithm in a computer program code, we look for what's its main drive? What's the strength of it? because that strength can either cause that computer to crash, or it may cause that computer to keep on running. What's the biggest term in it? The biggest term ahead is the x squared. If it's x squared, that means that it's what kind of equation? Okay. It's going to be a long evening, I'll tell you. These two over here. But yes, you're exactly right. Quadratic, right? I don't know why y'all sat so far back. I did brush my teeth this morning, but maybe that was too long ago. There's nothing wrong with these seats right here. But anyway, Tatum, you remember last time I had you all sitting right here, you know. You didn't want to sit up here close to. Okay, you want to. Huh? Yeah, you know, you sit up here, you know. But anyway, it's okay. So it's a quadratic. If it's quadratic, you want to solve by either factoring. You remember that? If it's quadratic, you solve by factoring. If you can factor, if you can't factor, use the quadratic formula. So if it's quadratic, for this one, you can factor. So quadratic. Here we solve either by factoring or by the quadratic formula. You know, there's a couple more ways. I think Tatum was saying that you can also solve by the so-called square root property. And that's another way that you can solve. And then the fourth way you can solve is by completing the square. So we got about 4 ways of solving a quadratic. It's just 2 of them. Solve by factoring or by the quadratic formula. So notice that isn't there an x common in x squared and 36x? It's a common x. So I factor out x. It's supposed to be a parentheses. This is x minus 36 equal to 0. So doesn't this imply that x is equal to 0 or x is equal to 36? Right? Do you see that? If it's x times x minus 36, either x is equal to 0, right? Or x minus 36 equal to 0. So you get x equal to 0 there, or we get x equal to 36. Look at the problem. It says, which of the following is a solution? It didn't say which of the following is the solution. Had that question in Bible study last night, because in Bible study, in Matthew chapter 8, it says that the Lord Jesus healed 2 men who were in the tombs cutting themselves. They were possessed by a devil. And then in Mark chapter 5 and Luke chapter 8, talks about the same story, it seems like. But in Mark chapter 5, it says it was only 1 man. Well, it didn't say it was only one. It says it was a man in the tomb cutting himself, and he was possessed by a devil. So my question to the class was, is there a contradiction in the Bible? Because one text says there's 2, and then over here it says there's 1. And they told me, because it's a pretty good Bible class, they said, no, there's no contradiction. And I said, indeed, you're correct. And they gave the correct answer. And their answer is similar to this statement right here. It says, which of the following is a solution to the equation? Now watch this. If it had said which of the following is the solution to the equation, then A, B, C, D, and E would all be wrong. If it said the solution. But here it said a solution, which implies that it may be another solution, which it is. It's 2 solutions, right? 0 and 36. But it says which one is a solution. And so in other words, in one of the Gospels, it says that the Lord healed 2. And the other Gospel, it says that he healed 1. But it didn't say that he didn't heal any more. Just said here, he healed 1 of these persons who was a leper. So there was no contradiction. Just the other Gospel just pinpoint just one of these guys. The other Gospel talks about both of them. So So here it says which one is a solution. And so 36. 36 is a solution. Any questions? Do you need something? Okay. Need a calculator? You come up here and get it. Make sure I get it back, okay? I'll probably forget to ask you for it, but just make sure you get it back to me. Thank you. For the right triangle, RST shown below, what is tan R? What is tan of R? So the tan was the what divided by the who. You remember that? Tangent. Yes, thank you, Tatum. That's those curly. What you have you eating? What was that? That was those Doritos, y'all. What was the commercial about those Doritos and the guy there going crazy eating those Doritos or something like that? Y'all see that commercial about the Doritos? Was it Tostitos? Oh, yes. Yeah, it's all the same. Yeah, that's right. Okay. So anyway, she's right. The tangent here of an angle is always the opposite divided by the adjacent. So the tan here of R is the opposite over the adjacent. Here this is R, so the opposite is R, and the adjacent is T. So R divided by T, looks like that guy right there. Okay. A chord 24 inches long is 5 inches from the center of a circle as shown below. What is the radius of the circle to the nearest tenth of an inch? We're looking for this R right here. This chord here, this line that goes from the center to this chord, if I extend that through, this also becomes a radius. This chord, being that, watch this, that this is the center, and what is formed here is a right angle, then that forces this chord, when it's being sliced here by this side that's 5, that I'm getting half of it. So this is 12 over here. This is 12 there. And with that, you can solve it. Without that, then you have to use methods like, you don't have to use this, thank goodness you don't, but you have to look at this and there's some methods where you extend this side all the way out. You form another chord over here and this chord over there, and it gets very technical. But here, this becomes easy because of how this chord of 24 is being sliced. It's being sliced right there from that center. And so this side here forms a radius. And so this is a bisection. It's being cut right in half. So if that be the case, then you're solving for the hypotenuse from the Pythagoras theorem. So this is, yes, this is R squared is equal to 12 squared plus 5 squared. So this is 144 plus 25. So R is equal to, and that's just 169. So R is equal to the square root of 169. What is that? 13. Yep. 13 squared is 169. Any questions there? Let me erase the stuff that you didn't need. Is everybody happy with that? Okay. I tell you, like my mama, speak now or forever hold your peace, right? Oh, you know my mama? I know. It's almost like we all got the same mamas, let me tell you. Let's see. Yes. So the length L in meters of a spring is given by the equation L is equal to 2/3 F plus 0.03, where F is the applied force in newtons. What force in newtons must be applied for the spring's length to be 0.18 meters? So what is F if L is equal to 0.18? So that's very straightforward. So we got 0.18 is here, this length, that's equal to 2/3 times F plus 0.03. So basically you just isolate the F, get the F by itself. So subtract both sides by that 0.03. So you have 0.18 minus 0.03 is equal to 2/3 times F. And then multiply both sides by, here, the reciprocal of 2/3. So that becomes 3/2 times 0.18 minus 0.03. And that's equal to F. And so just on your calculator, you work that out. And you get H, 0.225. And do you know how to get that number from on your calculator? Right. You're going to put what's inside the parentheses first. So you do that subtraction, 0.18 minus the 0.03. Whatever that number is, multiply it by 3 divided by 2, and you get 0.225, right? And let me tell you, that's another aspect about this test, is to be able to use that calculator to your advantage, to be able to work that calculator so you can get these numbers right. Okay. Let's look at this one. After a snowstorm, city workers removed an estimated 10,000 cubic yards of snow from the downtown area. If the snow were spread in an even layer over the entire rectangular football field shown below, about how many yards deep would the layer of snow be? Always you want to answer the question, what are they asking for? What are they trying to get me to do? And then secondly, what information am I given? Right, the given information. And then typically whatever you don't know is usually what you're trying to solve anyway. All right. So what do they want out of me? Well, they want you to take this big chunk of snow, which is 10,000 cubic yards, a lot of snow, and they want you to spread this out on a football field. The football field dimensions that they give you is two-dimensional, but the snow that they have is three-dimensional, right? It's cube, right? So it's yards times yards times yards. Here, the football field is, you got this length, it's 100 yards plus 10 plus 10, because they got some more over there, right? So it's 120, right, for this length, and then this width up and down is 53.5 yards. So what they're saying is, if you take a three-dimensional something, right, and divide it by a two-dimensional something, then what you have left is the surface, the one level that they're looking for. So I take this cubic dimension divided by the squared, the area, and I get what's called here just this surface lateral space that you're looking for. So let's see what they're saying. So you're going to take this 10,000 cubic yards is divided by here this area. So I have volume divided by area just gives me one dimension. It just gives me this surface that we're looking for if I spread that snow out on one level. So here this is 53.5 yards times, that's 120. And that gives me here this surface space. Right. So on your calculator, so you have, this is 53 times, well, 0.5 times 120, so that gives us 6420 yards squared. So this is 10,000 yards cubed divided by 6420 yards squared. I think that's probably with no S, but it's okay because I'm country. So then take the 10,000, divide that by the 6420. I need the decimal. Okay. I get 1.55763, something like that. So I get 1 point, for the approximation, 5, let's just round that up to 8. This is yards. All right. So here, this is giving us that height of the snow, right? So here, isn't that between 1 and 2? It's between 1 and 2 yards. That's the answer. But again, what are they asking for? Make sure I understand that. And then secondly, what information is given. And then typically, thirdly, what I'm looking for is usually in the unknown. That's what I didn't know anyway. I know this length of the football field. I know the width of it. But then they give me this cubic dimension. Well, if I know the length and the width of a football field, if I multiply them together, I get the area. So the cubic volume divided by the area will here give me this dimension that they're looking for. And this is 1.558 yards. And it looks like that's between 1 and 2. Yep. The hypotenuse of a right triangle, PQR shown below is 16. The sine of angle P right here is 3/5. So the sine is said to be the opposite over the hypotenuse. The opposite here is the ratio, 5. I'm going to put that in parentheses. And here, the hypotenuse is ratio is said to be 3. And then it says about how many feet long is QR. How many feet long is QR? No problem. So what you have here is this. Sine of angle P is equal to, what I have in parentheses is said to be the ratio. So here, sine of P is the opposite, that's QR, divided by the hypotenuse here, which is PR. PR. Brain doesn't want to function like it's supposed to. People say, oh yeah, that happens, with age, but mine's been like this for a very long time, I was like 4 and 5, 6 years old. It was like that. So I don't think it's age with me. I just think, I just need help. But anyway. Okay, so here the sine QR is the opposite, PR is the hypotenuse, right? But they give us that the that the ratio is set to be 3 over 5, right? And then they also give us PR. PR is said to be 16. So I got QR over 16 is equal to 3 over 5. So I can solve for QR. So QR is 3 times 16 divided by 5. Multiply both sides by 16. So 16 times 3 all over 5. You get the answer there. You get 9.6. G. Is that okay? So the next one. So the graph below shows the number of cars assembled in 4 cities. Some of it is somewhat truncated off, so I think we can kind of make out what's happening. To the nearest 5,000 cars. According to the graph, what fraction of the cars assembled in all 4 cities were assembled in, well, the only town that has a ville on it is this Coupeville, so we're looking for that. So to be able to calculate that, this so-called ratio or this fraction, you need to know how many is in Coupeville divided by how many is in the total. So how did I get there? It's funny. So we have, so the number of what's assembled in Coupeville divided by here the total number. All right. So Coupeville, that's going to be 2.5, right? 2.5. Then the total is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 2.5 divided by 10, what do you get there? Now it has a fraction over there, right? So we convert that to a fraction, if you will. Just multiply the top and the bottom by 10, so you get 25 over 100. You see that? Just want to get rid of that decimal. So 25 over 100 is 1 over 4. Is that okay? La, 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 la. Okay. There was some stuff cut off on this one. And it's that, okay, it says AD. AD. The length of AD is 30. Got that. AD is 30. The whole thing is 30, right? AC is 16. So AC that's 16. The whole thing is 30. One of these days, I'm going to get somebody that likes me, and they're going to put a chalkboard in this class, you know, because I'm just an old fogey guy. I just love chalk, and that's, you know, all this, even the whiteboard, I didn't like that because my hand, I'm left-handed, and so I'm kind of afflicted in my left hand, you know, crippled, and so my writing is bad anyway, and so I have to write slow. And the surface has to be coarse for me to be able to write, you know, really good. And so this whiteboard, it just writes so fast, and I hate that, and it's messed me up. And then they came along with all this computer technology, mumbo jumbo, splashy, nice, sophisticated stuff. Who cares, right? And so then even on this surface, it's just hard for me to write. So, yes, ma'am. You can, yeah. Yeah, I just prefer the old chalkboard. I had fun with that. That was back in the 90s. Okay, so it says BD is, oh boy. So I had to find out what that was. Thank goodness for Google. So what I did was I just typed this problem, most of it there in Google, and that whole problem came up online. And so I could see that the part that we can't see for BD here is 20. Yep, BD is 20. So BD is 20 units. Okay, so that was the missing piece. That's BD. BD. Fellow down in Orville where I'm from when I was little, we called him Big D. He was a tough guy. It's funny how when you're little, those guys that seem to be really tough and they look big, and then when you get older, you go and look at them and like, man, I can take that guy now, Big D. And he had a brother named Chauncey. They were both just tough guys. They looked like the Incredible Hulks and stuff, but anyway, I saw Big D now. He's about my height. I'm not that tall. But when I was like 6, 7 years old, Big D, he walked down through Orville, man, his arms out. He's tough, he's bad, everybody get out of the way. Here come Big D. Is anybody here kin to Big D, by the way? Okay. They don't want to talk about nobody's family member. I did that one day. Years ago, I was teaching on the Huntsville campus. And this man, about 10, 12 years ago, and I was talking about Dr. King and the Civil Rights Movement. And I was talking about where I'm from the Selma area, and talking about when the civil rights workers were confronted with the sheriff there in Selma, Sheriff Jim Clark, and how he came out with his clubs and all this stuff, and they were just really rough on our people. And I had a student in the class, and she said, I beg to differ with you. You're talking about my grandfather. So I thought her grandfather was, C.T. Vivian, which I knew it wasn't her grandfather. And I said, who is your grandfather? And she said, Sheriff Jim Clark. I said, oh, interesting. So I asked her some questions. She said, oh, no, nobody understood my grandfather. He was standing up for what was right. I said, you think that was right? To beat people down because they wanted to vote? So she had some words, and she dropped my class. But anyway, so I got to make sure now when I'm in a class that I'm not talking about somebody's relative. I don't want the college to get sued, and I want to try to keep a little bit job that I have left anyway. Oh, boy. Okay, so let's see what we have. It says to find BC maze. Find BC if it can be determined. BC. All right. Now, if you notice, they give you AC, right? They give you BD, but we don't know BC. But notice that AC and BD encompasses BC, right? That becomes what we call an intersection, right? They both share BC. That total, if we can get the total, so if I can add up, but when I'm adding up, I can't add a duplicate, right? I can't add a repeat. Notice with BC, and yes, notice with AC plus BD, if I add AC plus BD, I'm also adding BC twice in there, right? So when I do that, if I'm going to add AC plus BD, I got to subtract BC out to equal to the total. Do you see that? Because I'm adding it twice, so I take one of them out. Okay. So what this looks like is, yes, AC plus BD. But in AC plus BD, you've added BC twice. Let's take out one BC. What do we have? Okay, that's equal to the total. The total is AD. Well, I think putting all things considered, I think we have what we need. So AC, they tell us that that guy is 16 plus BD is 20 minus BC, I'm looking for that, is equal to AD, that's 30. Excuse me. So here this is 36 minus BC is equal to 30. So subtract 36 on both sides, I get negative BC is equal to 30 minus 36, that's negative 6, right? Subtract 36 on both sides. So BC is equal to 6, right? (36 minus the BC is equal to 30. Subtracted that 36 on both sides. A couple of ways you could do that. So we get 30 minus 36. So this is negative BC is equal to negative 6. Then divide both sides by negative, so you get what you want. BC is equal to 6. Any questions? Yes, sir. Is that okay? It's okay. All right. All righty. So what is the x coordinate of the point in the standard xy coordinate plane at which the two lines y equal to 2x plus 6 and y equal to 3x plus 4 intersect? Do you know what they're asking? Well, what is x and y, but really what is x? It says, what is the x coordinate? Right? So you got two lines. One is y is equal to 2x plus 6, and the other is y is equal to 3x plus 4. And they're saying, where do these two lines share the same point, x, y, but in particular, they just want the x value. Well, they share the same point. Here, you can set those equations equal to each other. Since it's y equal to this, and over here, y equal to something else. So if it's the same point, that means that x is going to be the same x, and y is going to be the same y. So you can set those two equations equal, and you can get it. So here, this implies that 2x plus 6 is equal to 3x plus 4. So I'm going to subtract 2x on both sides and then subtract 4 on both sides. So I get 6 minus 4 is equal to 3x minus 2x. So you get 2 is equal to x, and that's all they wanted was the x coordinate. Okay, so I think we just did like 31 problems, and I would say probably about 5 or 6 of those problems were somewhat challenging problems, but the other 26 or whatever so problems, 25 problems, seem to be kind of straightforward. And typically on that test, the ACT test, you're going to run into that where you're going to come to a problem where you may kind of scratch your head. Again, circle it, move on, work the next one, work the ones that you can do straight up. And then the ones you can't do, circle those, come back to it, so that you don't want to be in the situation where you're trying to do the problems 1, 2, 3, 4, 5. I'm not going to go to number 12 because I got to work number 8, but 8 is hard, so it takes you 4 or 5 minutes to work number 8. So then you've wasted that time on answering problems that you could have answered, because now the time is going to get you, because you really got, on average, 1 problem per minute, right? 60 math problems, 60 minutes. So there may be some of those problems you can do like in 20, 30 seconds. See, that's going to save you some time now for those harder problems that you'll come back to and work a little bit later on. So you run through the ones you can do, circle the ones you can't do, and then after you work the ones you can do, the ones that you couldn't do that you circled, you go back and you take a stab at those. Check your time. Make sure you have enough time to give to working those problems. So of those, let's say 6, 7, 10 problems that you may question, it could be 15, I don't know. Do your best. Some of those you might be able to get, but some of them, the time may get you. So if you have left like 3, 4, 5 problems that you could not do, have no clue, guess on those, okay? And then you're done. The time may get you. But try to answer all of them. The ones you can do. The ones you can't do, circle those, come back to them. All right? Any questions? We're going to stop there, and I will email you this information and then give you